Welcome to Queen Victoria's birthday. Yes, today is All Hail the Queen. Well, at least here in Canada. I'm not sure exactly if they celebrate the same one in the UK, but forever here it's been third Monday, is it? Or the Queen celebrates her birthday here. Even though she's long gone, it's still celebrated. Let's see, one, two, yeah, it's the third Monday of May all the time. So I have a few items from Aliexpress and then a box of stuff from Adafruit, and I've been experimenting with building Circuitpython. I was actually originally trying to do it to see if I could build Circuitpython for new Pico, one that's not in the Python downloads, but be able to adjust the pins. I haven't got that far, but I am getting comfortable with building Circuitpython now and all the stuff. But I did figure out, with the help of one of the Adafruit guys, getting the ESP32C6 to load CircuitPython, which, as a side note, lets us do ESP328266s. Those are the ones with little cameras on them. They're a dime a dozen bulk board, but there is no drive on either one of these controllers. They don't express a storage drive through the USB port, even though that the ESP32C6 has both the UART and the USB port, just like their bigger or alternate brother, the S3s and the S2s. So, not sure why, but maybe it's just a software thing that hasn't been developed yet. But it can be done. So, without the show going on, here is the first item on my Aliexpress. I saved a whole bunch of them up. So, and I can't even remember what these guys are. Ah, yes. These are ESP32C6s, but they're not the dev kit C6s. These ones are clone. Call it if you wish. You can tell a little bit because the boards are wider a little bit than the conventional one. So if we look at a conventional C6, and I have one here in a container. So this is the dev kit C6. And you can see it's a little narrower. So let's open one of these guys up. Now these particular two, I bought from one site 6 of them, but 2 of them are 4, 2 of them are 8, and 2 of them are 16 meg. And of course you have to pin them yourself. But you can see that it's slightly wider. You can see over here, it's kind of hard to see. It's slightly wider than the dev kit version. So, yeah. So these are the 16 ones, 16 meg. And did I put those? Oh, just a sec. I need this. Okay. So let's put my real dev kit back in here again. I don't want to get the 2 sets of stuff mixed up because this has already been cataloged and everything. So, but these have not. Okay, so what's in our next bag here? So these are actual dev kit ones. These are the ESP32C6 dev kit M-1. Now the M, a little bit of sticker tape here. So these guys here have a smaller of this up here. And I did check, and it's looking like this one compared to the C1. I think the C1 has, or this one of the two, have 2 more pins exposed. Now, it's this one. Okay, so these guys here, this one is the 8 meg version. And this guy here is another 8. I'm going to have to leave these in the bags because it's really, really hard to tell these guys apart. This is the N4. Okay, so these guys here, can't remember. It's another variant, and I can't remember why I got these particular ones. Oh, right. These are the ones with the display on them. Man, that display's crooked. This is an ESP 8266 with a built-on display. And I think I have 4 of them. Yeah. Oops. Suppose I should put these back in. Maybe I can lift the display and straighten it out. I don't know. Let's find out. Okay, and then we have so remember the axis thingy where you can put the camera on and turn it I put together last time? Well, these are their cousins, but they're all aluminum metal versions. I'll have to assemble them. So on to Adafruit. Oops. Bag 1, bag 2, bag 3, bag 4, bag 5, and then this guy. So I had this, but I was before I started anything, I did some trial runs, and I found it's just the surface was a little on the small side. This is its bigger cousin. This is the MHP 30. This is the MHP 50. Ooh, quite the book. In 19 languages. So this one has a larger surface area than this one. And nice little controls on the front. This one should make it a lot easier to do stuff on. And they gave me a nice flexible USB-C cord. Nice box. Smells so chemically. Wow. The English instructions are halfway in the manual. Yeah. So, just put it up here. So, bag number 1. So, this is I believe an 8 or 16 point capacitive. No, 8. So you can have 8 capacitive touches around this guy right here. This is another one of those 80XL gizmos. I bought several variants of them. I wanted to check different ones out. I think this is also one. This is a Trinky. I couldn't get these last time because they were out of stock all the time. But here you go. An RP2040 with all the bells and whistles. Card reader, button, I2Cs, debug port. By the way, the Metro refers to New York's subway system. It's really nice. This is a really nicely built board. Stem QT, boot button over here, reset button over here. Oh, having a reset on a RP2040 is really nice. And these are little feet for the bottom. But it's pinned out, so it's practically the same as the Arduino pins. Same Arduino layout as an Uno. So I've got ones with S2s, S3s, RP2040s. If you really want to get started and stuff, this is really a board to get into. And this, I have one other camera, but I had no case for it. This is a case kit, just like the previous one. So I can now put another one in case. That's the second one of those. 345. And then the LSM 303 AGR. Again, these are one of these ones in here is not cheap, but it's supposed to be super precise. It does all the axes. It does sensing of magnetic fields. It does G-force up to really high G-force. So that was number 1. Let's put this bag into the bag collection. Number 2. Okay, what do we got here? So I saw this and this looked interesting. It was a way of putting various feather parts and stuff onto here. I'll have to try it out. It's aluminum. And of course there's 2 of them. And then what do we got here? If I remember correctly, this is like a driver for a Neo. This is a way to control its strip. NeoPixel strip. And this guy here, another tri-axis, blah 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 type thing. This is NeoPixel one. This is a power thing for the little guys like this. No, like not like these. I don't have one sample here, but it's not a Trinky. It's is it a Trinky? I always thought the Trinkies were these guys here, but it's a really small one like that. Cutie pies. It goes on top of a cutie pie and gives you standard power to it. And then this was also out of micro light. Okay, so this is a battery charger. Again, it goes on top of cutie pies. This one here, I think this one's a different type of battery charger. But again, it goes on cutie pies again. What is this one? There's a BNO 055 and a BMP 280. I think this is a combination axis and temperature, I think, but I'm not 100% sure. I have to look that one up again. And what do we got here? This guy here. Max 544. Analog switch. You can control a switch through code. It's like turning it on and off. And then this guy here. This is like, I want to try these out because not all my GPSs work very well. But this is a small floor version. It's for costumes, but I think it's usable for some other stuff. Oh yes, the little gamepad thing. Yeah, let's try number 3. Why does it feel it's like something missing in here, but I don't know. The thing I forgot to buy last time for some screens was these ribbon cables. And then what do we got here? Another sensor. Screen thingy, I think. And this is like a itsy bitsy ESP32. And cutie pies. Oh, this is freaky. I can go to my other room and get a IBM mid-1980s Bucky Spring keyboard, big white one, right? And in it is what's known as an 8051. It does all the keyboard crap. Well, that whole thing, that 8051 and all its stuff, is actually here in this tiny little chip. This is what this actually is. So she made one just, I don't know. I don't know really what purpose it will be for, but it's kind of cool. And what do we got here? DVI for, this guy here These match out with a Pico. So the idea is you put it on to a Pico. And you can use, through the Pico and that, you have a DVI port. Or HDMI. Well, that's the funky thing about this. Technically, this is HDMI. But they call it DVI in here. It just goes to prove that DVI, HDMI, and DisplayPort at the most basic level, i.e. just the basic 1080p video at 60 refresh, the signals are all the frickin' same. So if anyone comes to you and says, oh, you can't put that cable on your monitor, it doesn't work properly, that DisplayPort to HDMI, as long as the monitor is 1080p, not higher, 60 refresh, not higher, should pass the signals correctly. And this is an Adafruit Trinky with a SHT41 on it. I think that's a temperature sensor thing. And then this guy here, infrared. So this is like the infrared eyes, I believe. And this one here, this one is also .7703. They're both the same. These are the eyes. This is a way to control PWM by software through here. Yeah. So there's another half to these, and that is the I can't remember. I'm pretty sure these are the transmitters, and there's a receiver side to the infrared too. More ribbon cables, longer ones this time. And what do we got here? Oh, I wanted some more RP2040 cutie pies, so I got them. That's a sensor, I'm pretty sure. LSM 6 directions, SO32. I think actually this might be another axis thing. What is this one? If you're doing the some of the Adafruit projects with like the playground, the blue fruit, that little flora, for example, this is a style of connector for that. You use alligator clips and cabling to connect everything. It's designed for like kids and more longer cables. So what do we got here? Another axis thing. Oh, right, the USB host best friend. So if you want to be the other direction, I think it is. You want to take 8 USB signals in. I'm not quite 100% sure how to use that yet. This is UPDI. I think this is a type of programmer. And this guy here, this goes on a Pi and gives it a UART port. In a sense, easier way to do UARTs out of a Raspberry Pi. And this guy here, more sensors, I think. Oh, right. This helps you change the I2C address of something. Another host thing. Okay, magnometer. Smaller those aluminum plates. Keys. 6 directions of things. Another one of those. Key caps. And what's this one? Itsy bitsy ESP. Oh yes. Very tiny S3. Now the whole point of this was this, because I find the key on here is too big. Did I solder this one on already? Yeah, I did. So here's an empty one. So I found this too high. And these are supposed to be low to the thing switches. So they go in. Okay. Did I get the wrong switches again? Damn it. Oh man, oh man, oh man. I thought I got the right switches this time. Apparently I still have the wrong switches. I mean, my original goal was something like a low-level switch on top of here. That sort of idea. And apparently I still have the wrong switch. White Kalen shock switches. No, they're not it. And they can go all in there. So that was another screw up. Still haven't got the right one I want. And then I have this. In theory, I have another one around here, except I can't find it. This is a Titanium as ESP3. It just says ESP room 32. I can't remember what's on here. Card reader, speaker port, reset speaker. And then we got I2C and 2 other 3-pin ports on here. So try not to lose track of this one. Now, technically there were 2 more goodies, but they're in the mailroom at work, and they came in when I wasn't there, so now what did I do with that? These guys. So I already experimented with this, I think, one of these two. So let's see. Yes. So these C6s, they don't show a CircuitPy drive. So, but you can flash them in the whole 9 yards. But you have to learn how to do. Let me just get my notes up on this. So the way you build CircuitPython is, first of all, you set up a directory that you're going to put everything in. Let me see. Let me find my directory here for this. Boards. Yeah. Okay. So there's a whole set of instructions on their site for doing this. So you unpack, you go and use Git and you clone the CircuitPython drive, which is what I did right here. When you look into this drive, you're going to see a whole bunch of stuff. What we really care about here is the, let's see, logo, ports, shared, test tools. Where's that directory? I think it's ports. Yeah, I think it's ports. And then you have to go into, in my case, expressive. Yeah, okay. So you work your way down into, now you're going to need to go and get a bunch of things. First of all, you need the ARM compiler that's native to AMD systems or Intel systems, right? So you can compile ARM code. And then you're going to need a bunch of Python stuff. Now, let me go see if I have the web page still up for all this. Okay, let's see. This screen, no. What is it? Scene 7. Yes, the web. Just give me a moment. Chrome is not pointing at the right thing at the moment. There we go. So building CircuitPython. So you have to clone the CircuitPython. You have to install a bunch of Python packages. Make sure your pip is up to date. That's what they really want you to do here. Okay. Now, pip is already installed. Now, this is something I've mentioned before. CircuitPython now has like 3 levels of scope. There's the global scope to the OS itself, Python. Then there's the scope of you in your directory. Then there is potentially the Pi virtual environment, which is like think of it as a little container. You're going to do all the stuff in it and nothing leaks out. Right? So we're not going that deep into it, but we are definitely doing at the user level. So when I do this code here, apt install python 3 pip, I've already done this because it's already part of the OS install. But what we're really after is, boy, I can't even type. Okay, I don't have it in here. Um, you think after doing it so many times, I would actually have memorized this. So first thing I did instead of that pip install is first of all, just make sure that the pip is up to date. I think my internet's acting very slow today. Yes, we definitely have an internet issue here going on. Just a sec. Gateway's up, but I'm not getting name resolution here. I have config. Oh, I know why. One of these days, I've got to fix this. There we go. So, pip's up to date. Go back to my ports expressive here. Then you do these requirements. It's kind of like a list of all these packages that Python wants to put in. So development ones, documentation ones. And funny thing is, you need Rust. And the funny thing is, this doesn't work. This Rust install, fine. This Minify doesn't work. In fact, there are two packages that just don't get installed based off anything, and I'm not 100% sure why. I actually had to do that command and then just pay HTML-minify and install it from the PyPy repo. And then the same thing for another one. I can't remember exactly its name, but it shows up after you try to do things. It says this isn't installed, and you do that, and then finally you get to move forward. So then you check out, you go into your CircuitPython directory. This one right here, right? Not the ports, but just the CircuitPython component here, right there. And you execute what you want to check out. And in my case, I'm not checking out main because main is actually a head. I'm checking out 904 CircuitPython, which you can do by just specifying the checkout. Then they do a bunch of talk about submodules and stuff. They use a makefile to achieve all this. So I do this, and you can just selectively, for example, for Raspberry Pi, you could just do that. But I'm not doing that. I'm doing the whole darn thing. So I have all the stuff, and it takes time. You might as well go away and have a coffee because it takes about 15 minutes, 20 minutes or so to get everything. I mean, it is a big tree. And then the pre-commit stuff. And then you build your little MPY cross compiler. And once you're there, you're actually ready to build CircuitPython. But since I was dealing with ESP boards, we get to go one step farther. See if this is the one. Yes, expressive builds. Brew is a Mac thing. So you need to add some more stuff to your install. That's Ninja Build and CMake. And this little funky thing here, that guy there just simply tells the system that if it gets the words Python, it really means Python 3. So in essence, it's just making a soft link for you if it has been done already. So once you're in the ports of expressive like that, you would say source ESP IDF / and install. Oh, did I do something wrong? Yeah, I did do something wrong. I typed in the wrong place. Work. Circuitpython. Circuitpython. Ports. Expressive. I was one line ahead of myself. So esp-idf install sh. This is making sure that your environment is up to date. And then, yeah, sure, why not? I'll do it their way. Export sh like so. So now we actually can build. Now we want to build, they don't build it with this command, this ISP build. No, they're using makefiles to do all this. And in our case, we want to do this. So I'm going to plug the board in. And it doesn't matter, you can use USB or the UART. So I have the board plugged in. See, we're plugged in. Okay. And on this one, stand cam. Hey, let's turn the stand cam on. There we go. So what this command does for us is it specifies the board we're going to build. In this case, it's a C1 kit. And in this case, it is... No, I have the minis on here. No good. We don't want the mini. I haven't tried minis out yet. Wrong one. C1s. So now I have C6. It should be DevKit C1, and it is 8. Like so.